Hi student, this is Sivakumar. 10th standard mathematics, chapter number 2, exercise 2.5. Arithmetic progression. In short form, we can say that is AP. Look at the definition. Let A and D be real numbers. Then the numbers of the form A plus D, A plus 2D, A plus 3D, A plus 4D, etc. It is said to form arithmetic progression denoted by AP. The number A is called the first term of an AP and D is called the common difference of an AP. Okay. The difference between any two consecutive terms of an AP is always constant. That constant value is called the common difference. If there are finite numbers of terms in an AP, then it is called finite arithmetic progression. If there are infinitely many terms in an AP, then it is called infinite arithmetic progression. Okay. I give an example for you. Look at the example here. 2, 4, 6, 8, 10, it is going on. It is uniformly increased that 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, it is going on. So what is given here? The difference between any two consecutive terms of an AP is always constant. Look at that. 4 and 2 difference 2, 6 and 4 difference 2, 8 and 6 difference 2, it is going on. That is constant, that is given here. That is called the common difference. So what is the common difference here? 2. Now, the nth term of an AP, that is denoted by Tn, formula here it is Tn, that is equal to A plus n minus 1 into D. Tn refers nth term. Okay. If a finite AP whose first term is A and the last term is L, then the number of terms in the AP is given by L, that is equal to A plus n minus 1 into D, or else n, that is equal to n, that means a number of terms. To find the number of terms, you can make use of this formula L minus A by D plus 1. Okay. Now, important note, if every term is added or subtracted by a constant, then the resulting sequence is always or also an AP. If every term is multiplied or divided by a non-zero number, then the resulting sequence is also an AP. The sum of three consecutive terms of an AP is given, then they can be taken as A minus D, A plus D. Remember, three consecutive terms of an AP, that is A minus D, A plus D, like that. Four consecutive terms of an AP can be treated as A minus 3D, A minus D, A plus D, and A plus 3D. Here the common difference is 2D, here the common difference is D. Okay. Now we can get into that exercise 2.5, problem number 1. Check whether the following sequences are in arithmetic progression. Totally 5 subdivisions are there. If the sequence is an arithmetic progression, the condition has to be satisfied. The condition is T2 minus T1, that is equal to T3 minus T2. Then only we can say the given sequence is an arithmetic progression. Now we can verify. Here T1, T2, T3. This is T1, term 1, term 2, term 3. I am going to find out T2 minus T1 first. T2 minus T1. T2 minus T1. T2, that is A minus 5. T1, that is A minus 3. That is equal to, write A minus 5 as it is. Then outside the bracket we have minus. So minus into A minus A. Minus into minus plus 3. Here plus A minus A get cancelled. That is equal to minus 5 plus 3, that is equal to minus 2. Now we have to find out third term minus second term. third term minus second term. Third term is a minus 7, second term is a minus 5. A minus 7, a minus 5. That is equal to a minus 7 minus into a minus into minus plus 5. That is equal to here minus a plus a minus a get cancelled, minus 7 plus 5, that is equal to minus 2. Look at that, both same, minus 2 minus 2. Since T2 minus T1 that is equal to T3 minus T2, the given sequence is an AP. Now subdivision number 2. Subdivision number 2 is the first term, second term, third term, fourth term. It is going on. Find out T2 minus T1 and T3 minus T2. If they are equal, AP or not an AP. Second term, that is 1 by 3 minus first term is 1 by 2. You know that 3 and 2 LCM is 6. 3 2s are 6, that is a LCM. So nothing common between 3 and 2. In that case, we just multiply 2 and 1. 2 1s are 2 minus 3 1s are 3. That is equal to 2 minus 3, that is equal to minus 1 divided by 6. Like that, you have to find out third term minus second term. Third term minus second term is, third term is 1 by 4 and the second term is 1 by 3 equals. Here 4 and 3 nothing common, so you have to write the LCM, multiply just 4 and 3, that is 12. Therefore, you just multiply, cross multiply, 3 1s are 3 minus 4 1s are 4. 3 minus 4, that is equal to minus 1 divided by 12. Here minus 1 by 6, minus 1 by 12, both are different. So how to write, since T2 minus T1 is not equal to T3 minus T2, the given sequence is not an AP. Have to write the result. Since T2 minus T1 is not equal to T3 minus T2, the given sequence is not an AP. Now subdivision number 3. So you are given that first term is 9, second term is 13, third term is 17, fourth term is 21, fifth term is 25. It is going on. You just find T2 minus T1 and T3 minus T2. T2 minus T1 equals, what's the second term? 13, and the first term is 9. 13 minus 9, that is equal to 4. Now we can find the third term minus second term. Third term is 17 and that second term is 13, that is also 4. Even that, look at that, 21 minus 17 is 4, 25 minus 21 also 4. You no need to find out that one. Just a T2 minus T1 and T3 minus T2 enough. Since they are equal, since T2 minus T1 is equal to T3 minus T2, the given sequence is an arithmetic progression. Now subdivision number 4. So you are given the first term is minus 1 by 3, second term is 0, third term is 1 by 3, and the fourth term is 2 by 3. You have to find out T2 minus T1. T2 is a 0, second term, and minus first term. First term is minus 1 by 3. That is equal to 0. Minus into minus plus 1 by 3. 0 plus 1 by 3 equals 1 by 3. Now, third term minus second term. Third term is 1 by 3 minus second term is 0. 1 by 3 minus 0, that is equal to 1 by 3. Even fourth term minus third term, 2 by 3 minus 1 by 3 also 1 by 3. So, they are equal. Since T2 minus T1 is equal to T3 minus T2, the given sequence is an AP. Now subdivision number 5. Look at that. First term, second term, third term, fourth term, fifth term, sixth term. It is going on. Alternate numbers, 1 minus 1, 1 minus 1, 1 minus 1. Now we can find out second term minus first term. Second term is minus 1 minus first term. First term is 1. Minus 1, you know that minus 2. Now third term minus second term equals, third term is 1 minus second term. Second term is minus 1 equals 1 minus into minus plus 1, that is equal to 2. Here minus 2, here plus 2, not equal, therefore the given sequence is not an AP. Outright the result, since T2 minus T1 is not equal to T3 minus T2, the given sequence is not an AP. So problem number 1 is completed, and I will be teaching problem number 2 in the next video. Thank you, children.